All right, so now we are going to take a look at another example that involves three lines. Okay, so we've got, it says graph the solution of the following system of inequalities, and you've got three lines here. So this first line is 5x plus 2y is greater than 12. We'll have to rewrite that. And then we have x is greater than or equal to 0, and y is greater than 0. So let's do our two easy lines first of all. So we have x is greater than or equal to 0. So this is going to be a vertical line, right, that goes through x is equal to 0, right? So that's right here. So it's going to be a vertical line that goes up and down right here. So pretty much what you got here is you got the y-axis, right? That's what you have. You have the y-axis. So we're going to put on our solid line because this has the line under it. And so we're going to take this and we're going to go and we're going to put a line right here, and that is our first line. And I am going to label these so that we can keep this all straight. So this is x is greater than or equal to 0 is here. And then when we shade it, it's going to be everything greater than or equal to 0 on x, which is basically the right side of the graph. So we're going to just put in a couple small arrows in here to kind of show that we're thinking about that. And now for y is greater than 0, that is going to be a horizontal line, right? And that goes through y is equal to 0. So that's y is equal to 0 is right here as well. So we're going to share the same point that we just used. We're going to take our line and we're going to make it a dashed line because there is no or equal to on that, right? And so we'll put this going through right here. It's a smidge high, but that's okay. Now we'll put our arrows on the end. And if it's greater than, that means it's going to be everything above this line, right? All those y values are what is going to work. So we can see right now that the one shared area between the two is in here. So my answer is likely going to be somewhere in here. All right, and so we got 5x plus 2y is greater than 12. So let's take this 5x plus 2y greater than 12, and let's rewrite this thing in slope-intercept form. Okay, so first thing we're going to do is subtract 5x. And keep in mind that, you know, you might get some kind of weird stuff going on when you do this, right? So you get 2y is greater than negative 5x plus 12. And then when you divide everything by 2 to get y by itself, you get y is greater than negative 5 halves x plus 6. All right? Well, actually, this worked out pretty decent, right? So we got 6, so we're going to go up to 6, and we're going to put a point. So we can see one area where it's already going to intersect this. And then negative 5 halves means down 5, so we're going down to 1, and then over 2. So we've got a line that's going right here. We have this happening here, right? It says it's greater than, right? So we are going to use our, oops, wrong thing. We're going to use, make sure our dashed is on. Yep, we're going to use our dashed line, and it's going to go through these 2 points right here. So we're going to have something that's going to look sort of like this. It's not the best, but close enough, right? Now, this one gets shaded. It says greater than. So if I did this right, it should be everything over here. And so now you have to find, where do all three of these things meet up? Well, all three of these things are true right here on this other side of this dashed line here. So let's take the point 4, 4, which I know is in all three regions. All right, so we're going to test the point 4, 4 and see if it works. So if I put 4, 4 in for both of these, it clearly works, right? It's, sorry, I'm having some glitchy going on here. 4 is greater than 0 for x. Yes, absolutely. 4 is greater than 0 for y. And if you put 4 in this, 4 times 5 gives you 20. And 4 times 2 gives you 8. And 20 plus 8 is 28. And that is greater than 12. So it worked, right? So what we're going to do is we're going to shade just this section right here, and it's got to stay right. So it's this area right here. It's got to be there, and then the dashed right there, and then the dash right here, and it's just this area here. It doesn't go over there, it doesn't go in here, it doesn't go down here, right? And so sometimes they might ask you to find like a triangle doing that, and then you would have to give vertexes. So you'd have to do these and see where they meet and everything like that. But for our purposes on this one, it's just doing this. Okay, so hope this is helpful to you, and I'm going to try and put together one more quick video for you.